Section 4.5 continued. Reviewing 3 of the terms that we talked about yesterday and adding in 2 more, phase shift and center line. We have our basic trigonometric equation up here, y equals a sine of bx minus c plus d. That's as complicated as an equation as you will see. A, absolute value of a, the coefficient on the trig function, remember, absolute value of that is the amplitude of the graph. Period of a graph is always found by taking 2 pi over the lead coefficient on x, so 2 pi over b. Increment, remember, is always the quarter period or 1/4 of the period. Those are a review of what we talked about already yesterday. 2 things we're going to add in now today are phase shifts and center line shifts. The phase shift is found by taking the entire angle, setting it equal to 0, and solving for x. The phase shift is the starting point of the graph. For all of the graphs that we did yesterday, there was no phase shift. That's why everything started at 0 on the x-axis. Center line shift is controlled by this d value right here. Anytime we add or subtract something from the whole function, that tells us where our center line is shifted to. And obviously it will be a horizontal line, so it's y equals a number. And remember, the amplitude is measured from the center line. So if we have a center line shift up 3 units, so our center line is y equals 3, and our amplitude is 2, that means our graph will now go from 3 up to 5, and from 3 down to 1. So make sure you're always measuring your amplitude from the center line. Okay, our first graph here, y equals 1/2 sine of x minus pi over 3. So now we're going to identify all 5 things and then graph the function. Amplitude is 1/2. Period, 2 pi over the lead coefficient on x. 2 pi over 1 is just 2 pi. Increment, 1/4 of the period, pi over 2. Phase shift. Phase shift, remember, is the starting point of the graph. I find the phase shift by taking the entire angle expression, setting it equal to 0, and we get our phase shift is going to be at positive pi over 3. Center line, whatever's being added or subtracted from the entire equation, in this case, nothing. So our center line is the same as what we did in all the ones yesterday, just at y equals 0. Amplitude is 1/2, so this graph is going to go up to 1/2, down to negative 1/2. Increment is pi over 2, but now our starting point is at pi over 3. So I'm going to backtrack here, and we're not going to even put in our y-axis yet. Anytime you have a phase shift in your graph, just draw your x-axis to start with. Starting point is at pi over 3. Now, from that starting point, we're going to add the increment 4 times, just like we did yesterday. Yesterday, it was easier because we started at 0, and we could just add the increment 4 times. Now we're starting at pi over 3, and we need to add 4 times to it, pi over 2. Need a common denominator. 2 pi over 6 plus 3 pi over 6 is 5 pi over 6. Add 3 pi over 6 again, we get 8 pi over 6. Add pi over 6 again, we get 11 pi over 6. And add 3 pi over 6 the last time, and we get 7 pi over 3 when we simplify. If I subtract our increment, 3 pi over 6, from this starting point, 2 pi over 6 minus 3 pi over 6. My next critical point over this way would be at negative pi over 6. So now this is why we want to wait to put in our y-axis, because remember our y-axis should always be drawn in crossing at 0. Well, 0 obviously is in between these 2 points, a little bit closer to negative pi over 6 than pi over 3. And now our amplitude up 1/2, down to negative 1/2. That should be the most difficult part of doing these problems. Labeling everything correctly. Once everything's labeled correctly, it's using the rules you know about sine or cosine graphs. In this case, it is a sine graph. We know sine graphs always begin on the center line, but now here's where you need to be careful. They begin on the center line at our phase shift value. The phase shift, remember, is the starting point of the graph. It's positive, so it is going to go up from there. Now it's a matter of filling out your pattern, connecting with the smooth curve, and you are done. We only needed to show one full period. There is one full period. Number 6, amplitude is 4. Period, 2 pi over the lead coefficient on x is just 2 pi. Increment, 1/4 of the period is pi over 2. Phase shift, take the angle, set it equal to 0. This time x equals 0, so our phase shift is at 0. Center line is not shifted, so that's y equals 0. There is no phase shift. It's at 0, so I can draw my y-axis in right away this time. Amplitude, this goes up to 4, goes down to negative 4. Increment is pi over 2, and we're starting at 0, so 0 plus pi over 2. Pi over 2 plus pi over 2. Pi plus pi over 2. And 3 pi over 2 plus pi over 2. This is a cosine graph that is negative. Negative cosine graphs start below the center line. And from there, fill out your pattern. Connect with a smooth curve, and you're done. Y equals negative 2/3 sine x for one full period. Amplitude, 2/3. Period, 2 pi. Increment, 1/4 of the period. Phase shift, there is none, so it's still at x equals 0. Center line shift, there is none, so it's at y equals 0. Since there is no phase shift, we can draw on our y-axis right away. Amplitude is 2/3. Starting point is at x equals 0, so we're starting at 0 and adding the increment. 0 plus pi over 2. Pi over 2 plus pi over 2. Pi plus pi over 2. And 3 pi over 2 plus pi over 2. This time we're dealing with a sine graph. We know sine graphs always start on the center line at our starting point. This time, though, the sine graph is negative, so that means it is going to go down to start. Number 8, y equals 2 plus 3 sine of 2x. Amplitude. Lead coefficient on the trig function is 3. Period. 2 pi over the lead coefficient on x is 2. So our period is pi. Increment. 1/4 of the period. Phase shift. Set 2x equal to 0. Solve for x. There is none. It's at x equals 0. Center line shift. There is a center line shift here. Our center line is shifted because of what we are adding to the whole function 2. So our center line is going to be at y equals 2. There was no phase shift, so right away we're going to go ahead and draw in our y-axis. There's our x-axis. Our center line, though, has been shifted up to y equals 2. So there's our new center line. Our amplitude, remember, is measured from that center line. So our amplitude is going to go up 1, 2, 3 units, up to 5, down 1, 2, 3 units, down to -1. Critical points, phase shift is 0, so we're starting at 0 on the x-axis, and we're going in increments of pi over 4. So 0 plus pi over 4, pi over 4 plus pi over 4, pi over 2 plus pi over 4, and 3 pi over 4 plus pi over 4. We're dealing with a sine graph. We know sine graphs start on the center line at the phase shift value. It's a positive sine graph, so it is going to go up from here. Fill out your pattern. And there's your graph. Graph y equals -3 cosine of 2x plus 4 pi for 1 full period. So we have a lot of things going on here in this graph. Amplitude, lead coefficient on the function, take the absolute value. That's 3. Period, 2 pi over the lead coefficient on x. Period is pi. Increment, 1/4 of the period. It's pi over 4. Phase shift. Take the entire angle. Set it equal to 0 and solve for x. Phase shift is -2 pi. Center line, nothing is being added or subtracted from the entire function. So that's y equals 0. This time we have a phase shift, so I'm not even going to bother putting in our y-axis yet. Just going to draw on the x-axis. Our phase shift is our starting point, so we're starting at -2 pi. We add our increment 4 times to get 1 full period. So -2 pi plus pi over 4. -2 pi with a denominator of 4 is that, and we're adding pi over 4. So we have 7 pi over 4. -6 pi over 4. -5 pi over 4. And -4 pi over 4. So we can see we have to add 1 more full period to get back to 0. So our y-axis is going to be way over here. Amplitude is 3. Graph is still going to go up to 3, down to -3. We're dealing with a cosine function. We know cosine functions start above or below the center line. This is a negative cosine function, so it's going to start down here below the center line and fill out your pattern from there. connect with a smooth curve, and there's your graph. We only need to do one full period. That is one full period, so we are done.